In this video, we're going to talk about identifying triangle similarity. So we've talked about, we know the theorems and postulates around similarity. Now what we're going to do is we're actually going to look at a couple of different triangles and determine if they are similar. So my first examples are using side, angle, side. So as it says in the name, looking at this first set of triangles, I can see 5 relates to 10 and 4 relates to 8 in using a scale factor of 2. So triangle XYZ is similar to QRS. Now, it is extremely important to name these triangles accordingly because we want the sides that are similar to correspond when we're naming. So the side XY is 5. I want the side QR, which is twice 5, to be corresponding when naming. Now, if I wanted to ask you what is the scale factor of for the similarity here, you would see take 5 to 10, which reduces down to 5 to 2. So a scale factor of 2, or a ratio of 1 to 2. So this next example, and side, angle, side, we know that angle Y and angle R are congruent because of the congruent marking. So now looking at the next example, I see the side lengths are similar, so 12 and 6 and 8 and 4 correspond with a scale factor of 2. However, I don't really see an angle. However, looking at these, notice these two vertical angles. Now, one of the few things we can always assume from a picture in geometry is that all vertical angles are congruent. So given that these vertical angles are congruent, I now have two sides and an angle between them to form similar triangles. So triangle AEB is similar to triangle BEC. Again, make sure you pay attention to naming so that you correspond with the similar sides. This next example has one triangle, but then DE creates a second smaller triangle. Now notice I see 12 and 6 and 10 and 5, so they again correspond to a common scale factor or a common magnitude. Now notice in the bigger triangle ABC and in the smaller triangle DEC, I have the same angle, C. So another thing you can assume from a picture is if I have an angle within both triangles, congruence is reflexive, meaning if it's in this triangle and this triangle, then it's congruent to each other. So in this case, I can say triangle ACB is similar to triangle DCE. And those are just some of the examples of side, angle, side, some of the more complicated ones that you have to kind of assume more information to keep going. So my next two examples are using angle, angle, and then side, side, side. So for angle, angle, again, notice from this picture, I can go ahead and say that these vertical angles are congruent, which would then give me two congruent angles in the triangles. And I would name them accordingly. So angle A would need to correspond to angle E. Angle B would need to correspond to angle B in the smaller triangle, and then angle C and angle D because it's left over. So triangle ABC is similar to triangle EBD. The next one, side, side, side. So notice here, I have these two triangles, and 4 and 8, 3 and 6, 6 and 12. So notice how 3 and 6. So this 6 exists, this side exists in both triangles. Now 3 and 6 are similar sides, and 6 and 12 are similar sides. So if I take these and take them apart, YZ in both triangles would be 6. But since they maintain a scale factor, I can say that they are similar. So triangle XYZ is similar to triangle. So notice XY is 4, so I want YW to be my next segment. XYZ. YZ is 6, so then I'm going to want my WZ to be the next side in the similar triangle. So it is similar to YWZ. So now let's say that we are given some information and I want to find more information. So looking at this example, well, we know that this angle exists in both of them, so congruence is reflexive. Tells me that this angle is congruent to itself. Notice how 5 and 10, 8 and 4 are both similar. So now I have side, angle, side similarity for these two triangles. So then if I want to find this missing side, let's set up the scale factor. So 4 and 8 has to be equivalent to 5 and 10, which has to be equivalent to x and 6. So in this simple example, we can kind of look at the pattern and see, hey, it's increasing by a factor of 2. So x would have to be 3. But in a more complicated example, you could take one of the ratios and simplify them down and then cross-multiply and solve for the missing side.